Okay, in chapter 2, we're talking about chemistry, and it says, what are you made of? Just as buildings are made from bricks, steel, glass, and wood, living things are made from chemical compounds. When you breathe, eat, or drink, your body uses the substances in air, food, and water to carry out chemical reactions to keep you alive. The first job of a biologist is to understand the chemistry of life. What three subatomic particles make up atoms?
Protons?
Good. 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 The subatomic particles that make up atoms are protons, neutrons, and electrons. The study of chemistry begins with the basic unit of matter called the atom. The concept of the atom came from first from the Greek philosopher Democritus. Say Democritus.
Democritus.
Nearly 2,500 years ago. That's a long time. Democritus asked, can you divide a substance without limit, or does there come a point at which you cannot divide the substance without changing it into something else? So he was asking, if I take a piece of iron and just cut it in half, cut it in half, cut it in half, cut it in half, does it come a point where I can no longer cut it in half and that it's no longer iron? Democritus thought that there had to be a limit, and he called the smallest fragment the atom, from the Greek word atomos, which means unable to be cut. Atoms are incredibly small. Placed side by side, 100 million atoms would make a row only about 1 centimeter long, about the width of your little finger. Everybody look at your little finger. Despite its extremely small size, an atom contains subatomic particles that are even smaller. The subatomic particles that make up atoms are protons, neutrons, and electrons. The subatomic particles in a carbon atom are shown. So this is the diagram of a carbon atom. This is in your book, and you can see some are positive, some have no charge, and some are negative. That's as easy as that. Protons and neutrons have about the same mass. Protons are positively charged particles, and neutrons carry no charge at all. Strong forces bind protons and neutrons together to form the nucleus at the center of the atom. When this atom's nucleus is split, the power that comes out of there is what they use to make atomic bombs. That's why they're called atomic bombs, because they come from splitting the atom. The electron is a negatively charged particle with only 1/1840th the mass of a proton. So electrons are in constant motion in the space surrounding the nucleus. They're attracted to positively charged nucleus, but they remain outside the nucleus because of the energy of their motion. Because atoms have equal numbers of electrons and protons, their positive and negative charges balance out, and atoms themselves are electrically neutral. The carbon atom shown has 6 protons and 6 electrons. How are all of the isotopes of an element similar? So you can have isotopes of aluminum. There are 5 different isotopes, but they're all still aluminum, and they all still have the same number of protons and electrons. They have the same number of electrons. All isotopes of an element have the same chemical properties. So it's the electrons that make up these chemical properties. A chemical element is a pure substance that consists entirely of one type of atom. More than 100 elements are known, but only about 24 are commonly found in living organisms. Elements are represented by 1 or 2 letter symbols. For example, C stands for carbon, H for hydrogen, Na for sodium, and Hg for mercury. And this is mercury. This is one of the few liquid metals. It's liquid at room temperature. The number of protons in the nucleus of an element is called its atomic number. Carbon's atomic number is 6, meaning that each atom of carbon has 6 protons and, consequently, 6 electrons. Atoms of an element may have different numbers of neutrons, though. For example, all of the atoms of carbon have 6 protons. Some have 6 neutrons, some have 7, and a few have 8. Atoms of the same element that differ in the number of neutrons they contain are known as isotopes. So isotopes are just, they're the same type of element, they just have extra neutrons. That's all. That's all it is. The total number of protons and neutrons in the nucleus of an atom is called its mass number. Isotopes are identified by their mass numbers. For example, carbon-12, carbon-13, and carbon-14, which is used for dating very, very, very old things. because these neutrons, the extra ones, they don't stick around very long. And they, as a matter of fact, for carbon, they know how long they stick around. So in a sample that has an average number, still very few, carbon-14 atoms, they say, oh, if there's only a couple left, we know how long it took for that to break down. And so 6,336 years old, they can tell by however much carbon-14 remains. That's how they do carbon dating. The weighted average of the masses of an element's isotope, in which the abundance means how much of each isotope in nature is considered, is called its atomic mass. Because they have the same number of electrons, all isotopes of an element have the same chemical properties. So again, it's the electrons, those things we're talking about, that make up the chemical properties for every single element. Some isotopes are radioactive, meaning that their nuclei are unstable and break down at a constant rate over time. Although radiation can be dangerous, radioactive isotopes have a number of important scientific and practical uses. Geologists can determine the ages of rocks and fossils by analyzing the isotopes found in them. Radiation from certain isotopes can be used to detect and treat cancer and to kill bacteria that cause food to spoil. Radioactive isotopes can also be used as labels or tracers to follow the movements of substances within organisms. Chemical compounds. In what ways do compounds differ from their component elements? The physical and chemical properties of a compound are usually very different from those of the elements from which it is formed, as in the sodium chloride example I gave you. A chemical compound is a substance formed by the chemical combination of two or more elements in definite proportions. Scientists show the composition of compounds by a kind of shorthand known as a chemical formula. Water, which contains the 2 atoms of hydrogen for each atom of oxygen, has the chemical formula H2O. The formula for table salt, NaCl, indicates that the elements that make up the table salt, sodium and chlorine, combine in a 1-to-1 ratio. The physical and chemical properties of a compound are usually very different from the elements from which it's found or formed. For example, sodium is a silver-colored metal that is soft enough to cut with a knife. Did I say that? It reacts explosively with cold water. Chlorine is a very reactive, poisonous, greenish gas that was used in battles during World War I. However, the compound sodium chloride table salt is a white solid that dissolves easily in water, is not poisonous, and it's essential for the survival of most living things. What are the main types of chemical bonds? You should have these written in those notes that I gave you for this color paper, because I gave you spots to put them. Put them there now. The main types of chemical bonds are ionic bonds and covalent bonds. I believe you have a field for each one of those. The atoms in compounds that are held together by various types of chemical bonds. Bond formation involves the electrons that surround each atomic nucleus. The electrons that are available to form bonds are called the valence electrons. The main types of chemical bonds are ionic bonds and covalent bonds. An ionic bond is formed when one or more electrons are transferred from one atom to another. An atom that loses electrons becomes positively charged because it has less negative particles. And an atom that gains electrons has a negative charge because now it has more negative electrons. And they show that to you here.
Ionic bonding is fun!
Yeah.